Okay, this screencast is about writing and balancing equations. So an equation is something where you show the reactants and the products together. An equation has to follow the law of conservation of mass, meaning whatever's on the left side of the arrow has to go into the same things on the right side of the arrow. They can be rearranged, but they have to be in the same quantity on both sides. So here's an example of balanced blocks. You can see on the left side of the arrow, or the reactants, you can see that you have some blue and some orange, and on the right side of the arrow you also have some blue and some orange. So you have the same color on both sides, but we also need to have the same number on both sides. And if you look on the left, we have 1, 2, 3, 4. So 1, 2, 3, 4 blue. Over here we have 1, 2, 3, 4 blue. Over here we have 2 orange, and on the right side we have 2 orange. So this one is considered to be a balanced chemical equation. You can do the same thing with element symbols as opposed to just blocks. For instance, here is a balanced chemical equation. You see that this is read as 2 NaCl plus F2 yields 2 NaF plus Cl2. Couple of notation pieces. If you see a triangle above the arrow, that means that heat is added to the reaction. And sometimes your arrow can have 2 heads on it. It's a double-headed arrow, and it would mean that the reaction can go forward or backwards. So some pieces in this balanced chemical equation are, you have things on the left of the arrow, which are the reactants, and you have substances on the right side of the arrow, which are your products. The arrow is the yields, or the equal sign. Kind of like in a math equation, you have an equals. So like y equals mx plus b. This is the reactants equals the products. The large numbers in the front of a formula are called coefficients, and these are used to balance the chemical equation. These are the numbers you get to add whenever you're balancing an equation. The little numbers, the subscripts, are part of the formula, and you cannot change these. You cannot add them when you're balancing an equation. You cannot change them. The only numbers that you may add are these large numbers in the front. You cannot manipulate the subscripts. You can't add a 2 in the middle of this NaCl. You have to put the number in the front of the whole thing. So if we look at this equation, we see that we have 2 Na here, and over here we have 2 Na, and we have 2 Cl because this coefficient distributes to all the parts of the NaCl. So we have 2 Cl, and on the right we have 2 Cl. We have 2 Fs, and here again this 2 distributes to this Na and the F, so you have 2 F. So this one is considered balanced. Again, we're following the law of conservation of mass, meaning no mass or energy can be created or destroyed. So what you have in the reactants, you must have in the products. Whatever substances you have on the left, you have to have the same quantity on the right. One little thing about when you're writing formulas from words, you might encounter things called diatomic molecules, and this means that these elements will always have a subscript of a 2 whenever they're in a formula by themselves. For instance, hydrogen is always H2. When in nature, when these elements are alone in nature, they always combine with themselves to have a compound of 2 of that element. Kind of like, you can have, if you go to the mall, you often see people moving in pairs. I used to say middle school girls at the mall, they never go anywhere by themselves. So consider the diatomic molecules as one of these pairs. They never go by themselves. Any other element, when it's in a compound, it will cross the charge. So these elements also, when they're in a compound with something else, they will crisscross their charges. But when they're by themselves, they have to have a 2. Any other element by themselves can have nothing on it and can be plain, considered plain. So you can have Fe and not have to have a number on it. A way to remember the elements in the diatomics, hydrogen, chlorine, iodine, fluorine, bromine, oxygen, and nitrogen, you can make it into a name. You can say that it's a book called Diatomics by H. Cliff Braun. It's just a little mnemonic to help you remember it.